Welcome to the project demonstration of Thermo Electric Power Generation using Peltier plates. So here we are going to generate the power by providing the heat, and heat energy is transferred to the electrical energy. So that electrical energy given to the battery charging section through this charging circuit. So this consists of a capacitor and diodes and rectification. So the rectifier won't work when we are providing the input from this Peltier plate, as it will generate the DC power supply only. So when we charge a battery with the help of transformer, so for the transformer charging, disconnect this G generator and connect the transformer T at this same slot, and you can switch on the power supply to the transformer. So then there is a light indication on the charging circuit. So the battery will be fully charged in a duration of 10 hours. So after that time completes, automatically the diodes will stop the current flow from the transformer to the battery. So you can disconnect the power supply. So a main execution consists of only Peltier plates. So after the battery fully charged, connect the Peltier plate over here. So the output from the Peltier plates, thermoelectric plate, so divided to two parts. One is to the voltage sensor, one is to the charging circuit. On the voltage sensor, we can see 10:1 ratio potential divider, that is 10 kilo ohm and 1 kilo ohm. So whenever the generator voltage is above 5 volts, in real time the controller won't measure that voltage without the voltage sensor, without the potential divider circuit. So we are going to dividing that, and so that we can measure up to 50 volts from this sensor. So that was given as input to the A0 pin of our PIC16F72 microcontroller, and the so-called voltage will be displayed on the LCD screen, which is connected at pin number B2 to pin number B7. So the whole system getting power supply from the battery. So as we discussed, the generator voltage from the Peltier plate will be given to the charging circuit, and from there given to the battery. So after that, so this is a main on-off switch to on the kit. And also we are going to provide this same 12 volts power supply to the inverter circuit. So here it has a two stages. One is the pulse generation, and another is the step up transformer. So pulse generation will provide us that 50 heads of pulses with 12 volts 1 amp, as we are using 12 volt 1 amp. This battery pack consists of 3 4 volt 1 amp batteries are in series. So we will get 12 volt 1 amp, and output is given to the inverting circuits. On this one, with the help of this IC, we are going to generate the 50 hertz pulses. So that is only 12 volts with less current, as the IC can generate only less current pulses. So that will be step up to the 12 volts pulses with the help of these two MOSFETs. So the MOSFET will provide us output of directly 12 volts 1 amp AC signal. So that was input to this step up transformer, so which will step up the 12 volts AC to 230 volts AC. So that is directly given to our load. So here the flow is finally like Peltier plate to the charging circuits, and voltage sensor to microcontroller, charging circuit to battery, and here battery to the microcontroller to measure the voltage and to work, and battery to the inverting circuits. On this one, two stages: pulse generation, step up transformer. And parallelly we are going to provide the same 12 volts power supply with the help of this switch. So main switch is on off, and then this is the on switch for this coolant fan. So it has a heat sink above and below also. So thus below heat sink will take the heat and distribute that, and next above plate is acting as a cooling plate for the Peltier plates. So whenever the heat is getting heat up, so as we know that Peltier plate is 4 mm thickness, so the other side heat also get be transferred to the other side. So in order to dissipate that, we are using this heat sink, and for cooling purpose we are using this coolant fan. So let us see demonstration. As of now, the zero voltage is coming out from the Peltier plates. When we switch on the heater, this is the heater power supply 230 volts. So when the heating is temperature increases, then the voltage also start increasing. So we can see that. And for the utilization for the fan, this is the main on-off fan. So when the temperature got increased after 10 to 15 minutes, so you can switch on that, so that it will be cooling, and Peltier plate will provide us a more voltage. And this is the main on-off switch for the inverter circuit. So as when you switch on the kit, inverter circuit, the 12 volts DC converter into the 12 volts AC, and that is again converted to 12 volts AC with 1 amp current, and step up to the 230 volts AC, so to the load directly. Right, when the temperatures increases, keep on, then the voltage also will be increased. So we can observe that.